Welcome to Brain Vision.
So this question asks us to derive Rydberg's equation from the quantum mechanical equation that is similar. So we start with the quantum mechanical equation, which is En equals negative 2.18 times 10 to the minus 18th joules times 1 over n squared, where n equals 1, 2, 3, etc. It can be any integer. Then we move into the delta E between states is Em minus En. So this is just the energy of two different states subtracted to find the delta E. And so if we plug this into the equation above, we get delta E equals negative 2.18 times 10 to the minus 18th joules times 1 over m squared minus 1 over n squared, where now we have two different states, m and n. So to move on from here, we take that the energy of a photon is equal to negative delta E of an atom, and our previous equation was for delta E of an atom, so now we can combine those two equations to find that the energy of a photon is equal to 2.18 times 10 to the negative 19th joules times 1 over m squared minus 1 over n squared. And we also know that the energy of a photon is equal to hc over lambda, the wavelength, where h is Planck's constant and c is the speed of light. So if we now plug this into our equation, we end up with hc over lambda equals 2.18 times 10 to the 19th joules times 1 over m squared minus 1 over n squared. Now our last step is simply to divide by hc so that we have the proper 1 over lambda over here. And once we divide by hc, this 2.18 times 10 to the 19th joules divided by hc is equal to RH, or the Rydberg constant. And then we still have our 1 over m squared minus 1 over n squared. And so now we have derived the Rydberg equation.